Minimize it. Now, let's talk about trig. What math are you taking right now?
Algebra 2.
You are a junior.
Yes.
You probably had a little trig in geometry, I'm guessing.
Yeah, I'm pretty sure.
Okay, do you remember much of it?
No.
Give you the very basics. Because there are like 4 trig questions on the test out of 60. So you could miss all 4 of them and you'd still be okay. It wouldn't be deadly. But if you learn just the basic trig stuff, you can probably get 2 out of those 4 questions right. So I think it's worth us covering just the basics. Okay. The most important basic. What's the rest of it?
Isn't it
So what?
Bocatoa?
Spell the rest of it.
Oh.
How do you spell the ka? So it's actually so ka toa. So
C-A-W?
C-A-H, that's the
Oh.
ka.
W. Why did I say W?
And the reason the spelling is important is because this tells you what each one is. This tells you that the sine is the opposite over the hypotenuse. This one tells you the cosine is the adjacent over the hypotenuse. And this one tells you the tangent is the opposite over the adjacent. Okay? So that's why they teach you this expression, so katoa. Now, I'm going to draw a triangle, and I want you to give me the trig functions of based on what you're looking at on this page, tell me what the sine of theta is. We always take trig functions of angles, and we always get ratios. Always. Notice that the top line there are fractions, every one of them. So what's the sine of theta?
Would that be no.
Yeah, it's this
Opposite
one
over
right here.
hypotenuse?
What is it?
Opposite over hypotenuse?
So what are those numbers? What's the opposite side?
Is that 5? Yeah.
4.
No, oh yeah,
The way to find the opposite side of an angle is just to follow its 2 rays until they connect, and that's the side. In other words, 4 is the opposite side of theta. So that would be 4 would be the opposite. The hypotenuse is always opposite the right angle.
So 5.
So 4 over 5. That would be the sine of theta. Now tell me what the cosine of theta is.
3. Wait, hold on.
Ratio. So what's the numerator? What's the denominator? What's the adjacent side to theta?
The adjacent side, that's 3, right?
Actually, there's 2 of them. There's 3 and there's also 5. But when they refer to the adjacent side, they are referring to one of the short sides, never the hypotenuse. So it's definitely 3. It's not 2 different answers. It's only 3. Also over the hypotenuse, so that's 3/5. And now finally tell me what the tangent of theta is.
It would be 3 over.
Hold on. Opposite first.
Isn't the opposite?
What's the
Oh,
opposite?
4.
Theta. Okay. So 4 is in the numerator. What's
And
the
then 3.
4 over 3. So that's a lot. What you're looking at right there, guaranteed, will get you 1 trig question correct. Okay?
Okay.
Now, let's look a little further, and you're going to see something here that would get you the answer to this problem. Let me put another angle on there, alpha. Okay?
Mm-hmm.
That's the other short acute angle. Every right triangle has 2 acute angles. What do they total?
What is what?
What do they total, those 2 angles?
45,
90.
90.
In other words, the sum of the angles of any triangle is 180. Okay? Well, that right angle is 90. So if we subtract 90 from 180, that leaves 90 for the other 2. Okay?
Mm-hmm.
Now, tell me what the sine of theta was again?
Sine of what, sorry?
Sine of theta?
Is it the 3 over 5? Is that the one that you're talking about?
Sine is the S.
Yeah.
So it's
Wait.
opposite over hypotenuse. What's the opposite of
4,
theta?
4 over 5?
Okay, that's what it is. Okay. Now tell me what the cosine of alpha is.
Oh. Cosine of alpha.
Adjacent over hypotenuse.
The 3 over 5.
What is it?
3 over 5?
That was the cosine of theta. We're talking about this angle here now. When you switch angles, it changes everything. So
Oh, so
you're looking for the cosine of alpha, you have to take the adjacent side to alpha, which is 4, over the hypotenuse.
would
So,
that still be 5?
so it's 4 over 5, not 3 over 5. You said 3 over 5.
Mm-hmm.
Now, notice that they're both equal. Notice something else is that alpha is 90 degrees minus theta.
Mm-hmm.
So if I said the sine of theta is equal, it has to be equal to the cosine of 90 degrees minus theta. Always, no matter what theta is. That is a truism of all cofunctions. Now, let's just talk about cofunctions. What's the cofunction of sine?
The cosine of sine?
Cofunction means you stick the letter CO in front of it. What's the cofunction of sine?
What? What? Oh,
Stick the letter CO in front of sine. What do you get?
cosine?
Okay, that's the cofunction of sine. What is the cofunction of tangent?
Cotangent? Oh,
It
yeah.
is, yes, it's as simple as that. What is the cofunction of secant?
Cosecant?
Every one of these has this property of 90 degrees minus theta. And vice versa. By vice versa, I mean the cosine of x equals the sine, which is its cofunction. In other words, if it already has a co to begin with, the cofunction is drop the co. Whatever you get, that's the cofunction. Okay? So that is true also. So it works all 6 ways that a trig function is equal to its cofunction of 90 degrees minus that angle. So they told us that the sine of x was 4/5. So what is the cosine of 90 degrees minus x? This is a grid-in part. So you have to grid in an answer. It's not multiple choice.
Wait, so 90 is 4/5, and then would you do 90 minus 4/5? Is that what you're doing?
No. Look at that I'm underlining right there.
The right angle, one angle measure. Cosine 90 minus 4/5.
Not minus 4/5. In other words, the sine of theta was equal to 4/5, right?
Yeah.
That means the cosine of 90 degrees minus theta is equal to 4/5 also. 4/5 is the answer.
Okay.
Don't plug in 4/5 for x. Remember what we're doing with trig. A trig function, you take a trig function of an angle and you come up with a ratio always. So if the sine of any angle is 4/5, we don't care what the angle is, that would mean the cosine of 90 degrees minus that same angle is the same. It's always the same. It's 4/5.
Okay.
In other words, let's take a real common one, the one you most want to remember. The sine of 30 degrees is 1/2. Okay?
Okay.
That's true. Sine of 30 degrees is always 1/2. Doesn't vary. Okay? So, if I said to you, what is the cosine of 60 degrees? What does that equal to?
2/4.
The sine of x, meaning any angle, is equal to the cosine of, would you give us an answer?
What? Wait.
What did you just give me as an answer?
2/4. I'm confused.
Well, I'm really confused because that's the correct answer, but why would you state it as 2/4 instead of 1/2?
I don't know.
Huh? In other words, yes, no matter what the angle is, the sine of that angle is equal to the cosine of 90 degrees minus that angle. Okay, and in this case, the angle was 30. Therefore, the sine of 30 equals the cosine of 90 minus 30, or cosine of 60. So whatever I got for the sine of 30, which was 1/2, it's the same as the cosine of 60.
Okay.
So the answer is 1/2. You might not get credit if you put down 2/4. Seriously. They always want you to simplify fractions. You never want to put 2/4 down as an answer anywhere on any math test.
Okay.
Okay? All right. Well, it's enough of trig for the moment. We'll keep going until we get another trig question, and then we'll look at more trig perhaps. There's a point of diminishing returns where we don't want to give you, spend all of our time on something there's only going to be 4 questions on. So we got a equals 5√2, and we got 2a equals √2x. They want to solve for x. How you doing? Now, this is the last question of this section. So you could say it's difficult. And notice once again that it's short. It's only one sentence long. So remember that when you take the test. When you're trying to figure out if a question is difficult or easy, that is easy, even though it's 8 sentences long. This is not that difficult. To be honest with you, I'm surprised that this is the last question in this section. It really isn't difficult at all. I want you to use substitution to solve this.
Okay, 2x. 2a.
What's a equal to?
2?
What is a equal to? I just circled it. What is a equal to?
Do I put it when I put in my calculator as like 5?
Forget your calculator. You don't want your calculator. You're not even allowed to use it on this section. There are very, very few problems where your calculator is going to be beneficial to you. It just isn't. It's going to be beneficial to you when you're doing arithmetic. This is algebra. So it's not going to help you a bit here.
Okay.
What you have is 2 equations, and you have 2 unknowns. You got an a and you got an x. So how have they taught you to solve a system of equations? They've taught you either substitution or elimination.
Yeah.
Let's use substitution. We
Okay.
have a fully defined. What is a equal to?
5 square root 2.
Okay. Now, let's go to our second equation. What should we do?
You would...
It's called substitution for a reason.
You would
Substitute what a is for a in the second equation.
Okay.
So, tell me what to write for the second equation. We're dealing with this equation now. You know what a is. Tell me what to write.
Would you do 3a? I couldn't. No.
Substitute. Don't try to do the whole problem in one step. You can't do it. Do it in multiple steps. This is one of the most common mistakes I see in math. People don't want to do it one step at a time. Math is extremely simple. If you just do it one step at a time. So substitute. What are you going to substitute for? You don't know what x is, but you know what a is, right?
Mm-hmm.
Okay, so go to the second equation and substitute for a.
Would you do 1a?
Well, it's 2 times a. So there's the 2. It's times, and instead of a, I'm going to write 5 root 2, which is what a is equal to.
Oh.
And now that whole thing is equal to the square root of 2x. Now, why is that beneficial? Because now we have one equation only and one variable only. A has gone away. So we don't care about a anymore. Now we have to keep going. We have an equation we got to solve. What's the next thing to do?
Divide it? Can you?
Now what
Wait.
you're trying to solve now is you want your last step to say x equals. Okay? So, given that that's what you're trying to solve for, what is the value of x? Okay? Well, the way we're going to solve for x is by isolating it. It's the way you solve every equation in the book, is by isolating the variable you're trying to solve for. So we got two other things going on over here. We got a radical sign and we have a 2. We got to get rid of both of those. Okay?
Okay.
Let's get rid of the radical sign first. How do you get rid of the radical sign?
I don't know how to go. Don't you? Hold on.
It's really too late to be looking this up in your book. It really is. You're not going to find the answer in your book. You have to know how to get rid of a radical sign. If I said to you, 5 equals the square root of x, what would x have to be? And how do you solve for it?
Why am I blanking right now? Oh my gosh.
You square both sides. Okay? So if I square that and I square that, well, when I square the square root of x, I get x. And when I square 5, I get 25. So that's how you solve for it. Well, we're going to do the same thing down here. We're going to square both sides. But before I square the left side, I'm going to simplify it. I'm going to multiply the 2 times the 5. So I'm going to have 10 root 2. That's what the left side is. And that's equal to the square root of 2x. Now, square both sides. What do you get when you square the left side?
20 square root 4?
It's 200 actually.
Oh, duh.
In other words, you got to square the 10, which is 100. And then you got to square the root 2, which is 2. So then you have 2 times 100, which is 200. When you square the right side, you just lose the radical sign. It's real simple. When you're squaring something that's nothing but a radical sign, you just drop the radical sign. Okay? Now I've got 200 equals 2x. What's the last step?
Divide it.
Be more specific, please.
Divide by the 2.
Divide both sides of the equation by 2, giving you x equals 100. Remember, you got to come up with this answer to fill it in. You can't say divide by 2. You got to come up with an answer. Okay? These are fill in. Okay. Now, let's see what next they have in store for us here. Okay, this is back to calculator section. But once again, do not be so inclined to reach for your calculator. There are very few problems that the calculator actually helps with. There are. It as frequently sends you in the wrong direction as it helps you. Seriously. You'd almost be better off not having it with you, except you kind of need it for arithmetic. And if you have to use it for arithmetic, use it for arithmetic. It's better than making mistakes. All right, question number 1. Now, it's a little tricky. Go ahead and read the paragraph.
Don't know what to see the part of the string. Graph shows the target. heart rate at different times.
This
Increasing
was,
then.
that's the strict, oh, hold on, I gotta take a picture of this. That's increasing. That's decreasing. But on that first one, it increases and then stays flat and then decreases. So that changes everything. On which interval is the strictly increasing, then strictly decreasing? I only see one spot on the whole thing, and that doesn't work. That starts by going up, and then goes down, but then goes back up, and then goes flat. So what are we missing? What we're missing is we didn't bother to look at the answers. The answers are not either that one, or that one. That's not what they're asking. They're asking what interval. In other words, it doesn't have to be the whole thing. What interval? Look at some of these answers. Between 0 and 30. That doesn't work. Between 40 and 60. Bingo. That works. Between 40 and 60, it's going strictly up and then strictly down.
Yeah.
So this was an easy problem, as it should be, being number one. But it was tricky because the mind automatically looked. The first time I saw this problem, I said, well, that must be a typo, because none of these goes strictly up and then strictly down. But once again, they weren't asking which of the curves goes strictly up and strictly down. They were saying which time interval does it. Okay, let's look at number 2. All right, so we're going to start here with what they gave us. Okay? Yeah. Now, we don't know what K is. This is one of those, this is a direct relationship, but you don't really need to know that. You don't need to know the terminology. Is all you need to figure out is what are we going to do? They're giving us some y and they're giving us some x. Well, what should we do? What's the only logical thing to do?
Well, there's a y and an x for the...
Let's plug it in.
Yeah.
You're saying y is 24. Well, they didn't give us a k, but they gave us an x when x is 6. What does that allow you to solve for?
Dividing it, I think.
What does it allow you to solve for? It allows you to solve for k. Okay, so solve for k.
Wait, 6.
You were correct, dividing. So divide.
4.
Okay. So now that we've solved for k, we can go back into this equation and give the specific equation. Hold on one second. Hey, son, I have an hour and a half tutoring ahead of me. I'll call you when I'm done. I'm in the middle of a session right now. Okay? All right. I'll I will. I'll definitely want to ask you about it, but I'm in the middle of a tutoring session right now. Bye-bye. All right, so if we go back to our original equation, now we know what K is. So that is our specific equation. This is called the general equation. This is our specific equation. Now that we have the specific equation, is all we had to do was solve for K. That was easy. Now we can answer their question. What's the value of y when x is 5?
It would be 20.
Okay, very easy. All right, number 3, parallel lines. Very important. They're going to have a lot of questions on parallel lines and transversals. There's few things they like to test on more than this. And they like to fool you. They don't just like putting 2 parallel lines and 1 transversal in there. They like to mix it up. They sometimes will make it look like that. And so you got lines everywhere, okay? But there is a fundamental rule that is very, very simple. What is the measure of angle 2 if angle 1 is 35 degrees?
If angle 2, if 1 is 30, what?
Angle 1 is 35 degrees. And they're saying, what is angle 2? I'm asking directly because if you don't know, we need to go over parallel lines with transversals.
Well, when you do 180 minus 35?
Yep.
So 145?
They're always supplementary. Whenever you have 2 parallel lines with 1 transversal, all of the angles, the acute angle and the obtuse angle, always add to 180, always. So this question was super easy from a number of perspectives. Look at the answers, first of all. Every answer on there is an acute. That's acute, acute, acute. Well, is that an acute angle?
No.
So they give you the answer by just showing you the picture. Don't ignore things like that. That can be extremely helpful. Now, the one problem with that is that maybe has a little perspective built in, and so you can't be certain that that's an obtuse angle, but you kind of can. In these SAT questions, when you see a picture like that, that definitely is an acute angle, plus they tell you it is. It's 35 degrees. And it looks 35 degrees. Therefore, that's definitely obtuse. There's only one obtuse angle on there. So, you didn't really have to know much about You didn't have to know much about parallel lines and transversals for this problem. You just needed to know about acute angles and obtuse angles. Okay, number 4. Remember, we're in the easy section, so this should be one you should know how to do. You want to try to do it.
Okay. If 16 plus 4 plus 10 more than 14 was the value of x. If 16 plus 4 plus 10.
Give me that as an equation. You always want to solve these by finding the equation and then solving the equation. Tell me what that is as an equation. Convert it, the sentence, into an equation.
16 plus 4. Wait, is 10 more than 14.
Hold on. That's not what it says. It says 16 plus 4x.
Oh. Is 10 more than 14?
What does the is mean? Is means what? Equals.
Yeah, equal that.
Is always means equals. Now what is 10 more than 14?
10 and then the, what's that thing called?
Plus sign?
No. Yeah. Is it plus sign?
Well, read the words. Don't
yeah.
overthink these. These aren't hard. What is 10 more than 14?
10 plus 14?
Don't give it to me like that. What is 10 plus 14?
24.
Okay, that's what goes over there. Now, what's the next step? In other words, we can always solve that. We know we can solve that for x, right? You have one equation, one unknown. You can always solve it whenever you have one equation, one unknown. What's the next step?
Subtracting the 16.
Good. Now tell me the next line.
4x equals 8. And then...
Now, I could solve for x. It's equal to 2.
Oh, so...
And then I'd multiply that 2 by 8 to get the answer of 16. But notice that I already have 4x. What's the relationship between 4x and 8x?
2.
Correct. So if 4x is 8, 8x is twice that much. 8x got to be 16.
Okay.
Okay. But the key is always being able to write what you see in a sentence into an equation. And the key words you're looking for are words like is. Is means equal sign. More than means plus sign. Less than means minus sign. Got to be able to turn it into an equation.
Okay.
Now, number 5.
What?
This is the second question out of the last 3 that kind of deal with these direct or inverse relationships between two variables. In other words, we just had one where y was equal to kx. That's a direct relationship. When x goes up, y goes up. Okay? A negative association means the same as an inverse relationship. An inverse relationship means when one variable goes up, the other one goes down, and vice versa.
Okay.
So which one best shows a strong negative relationship? And if you want to know how to do these, just take a pen and try to draw a straight line as best you can amongst the dots. Is that a negative relationship? Number C?
No.
That's a positive relationship.
Mm-hmm.
That's not the answer. Is that a negative relationship?
No.
Okay. Now here I'd be tempted to draw that. Is that a negative relationship?
No.
Actually, maybe. Not a good one, but yeah, you're right. It would be, I'm going to be even hard pressed to show that one. But if I get down here, is that a negative relationship?
Yeah.
Even if this one is negative, this one is much better. And the reason is there's less scatter. Look at how far in answer A, look at how far all the dots are from the line I ended up with. Whereas in answer D, the dots are all pretty close to that line. Well, the closer those dots are to that line, the stronger that negative relationship is. Okay?
Okay.
And the same thing holds true if I have something like this. That's definitely a positive relationship, but not a great one. Not like if I had a dot there, 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 and there. That is a good positive relationship. There's no scatter there. There's a little bit of scatter there. And that scatter is a measure of standard deviation, in case you're wondering. You're going to get a little statistics also if you haven't had it. You'll probably get it at the end of this semester. And standard deviation is a very common term in statistics. And what it is a measure of the distance, basically the measure of the spread of the dots. Clearly, in the problem we had, the measure of that spread is a lot bigger than the measure of that spread. And in this spread up here, I could just as easily draw a flat line through it, right? I mean, I'm not even sure that the negative slope was the best line, but it's definitely no comparison between A and D in terms of the quality of the association between the variables. All right, let's look at 6.
Decagram containers based on the information given in the box above them. Doses are there in 1, 2 decadon containers.
Okay. So let's start this in the order of the information they give us. That's the first thing you want to underline. How much is in that? Based on the table.
That'd be 20 grams.
Okay. So 20 grams is what these containers hold. Now, what does that say?
1 gram equals 1,000 milligrams.
So about how much do we have in milligrams? Remember, they're asking how many milligrams are there in this 20 grams?
20,000.
Correct.
Oh, that was an easy problem.
It actually was. You just have to look at it in the right sequence, and usually beginning to end is the best sequence for those. Not always. A lot of word problems you want to start with the last sentence, but not these. These are actually kind of the type problems you're going to see on this SAT. Are you taking the SAT at any point?
Yeah, I'm taking the SAT.
Oh, that's right. This is the SAT. I'm sorry. I've been doing ACT tutoring also. ACT has a science. Are you taking the ACT ever?
I don't think so.
Okay. It has a science section, and the kind of problems they ask in the science section are like number 7. It's not really a science section. It's a reading charts, graphs, tables, things like that.
Oh.
Okay, so they're asking you when you look at a chart, look at 3 things. Look at the title. Title's the first thing you should look at. Figure out what the horizontal axis means. Those are the cities, 5 cities. And figure out what the vertical axis means. That's the number of installations, but it's not in these numbers. What is it in? In other words,
wouldn't it be D?
Well, let's figure it out. Okay. If the total number of installations is 27,500, well, let's just figure out what we got here. We got 9 there. We got 5 there. We got 6 there. We don't know if these are thousands, hundreds, or what, but we're going to find out. We got 4 here. We got 3.5 here. Okay. If I add up all those numbers, that's 27.5. So, if they're saying that 27.5 is equal to 27,500, then what should the vertical axis actually be labeled in? Is it going to be in hundreds or thousands?
Hundreds?
Thousands. This is 27,000. Corresponds to 27 over here. That means that's not 9. That's got to be 9,000. This has got to be 5,000. In other words, if I make the vertical axis in thousands, then when I total them all up, I get 27,500. If your life depended on it, that's what you'd do. You'd say, okay, hundreds I think is the answer, so you make it hundreds. That makes that 900. Makes that 500. You total them all up, you're not going to come to that number. So you know you're wrong. So now you go back and you say, okay, let's make it thousands. Now, if I make that in thousands, then that is 9,000. That's 5,000. Now I total them all up. I get 27,500. That's got to be the answer. All right.
For what value?
Number 8.
Equal to 0. For what value of n is n minus 1 plus 1?
So tell me, can that be right? Let's back solve this one. This is a really easy one to back solve.
No.
0 doesn't work, correct?
Yeah.
Because the absolute value of minus 1 is actually 1. And 1 plus 1 doesn't equal 0. Okay, how about 1? Does it work?
No.
2, does it work?
Yes.
2 minus 1 is 1. 1 plus 1 is not equal to 0.
Okay, yeah.
What's our answer?
D.
Automatically. If you can absolutely rule out 3 answers, then whether you understand it or not, the 4th one is the answer. And it's actually pretty clear. Absolute values always give you positive numbers, correct?
Mm-hmm.
No matter what they are, whether they're negative or positive, they give you positive numbers. So I've got a positive number, and I'm adding to it 1. There's no way that can ever be 0. The only way that's ever 0 is if that is negative 1. And I'm just saying it's positive, always. So it's impossible for that to be true. Okay? And this is rare. You rarely ever see that as an answer on the SAT. You know, every now and then you'll see not enough information to determine it. I tell people don't ever guess that. If you're guessing, don't guess that. If I was looking at this and I had 2 seconds to guess at it, I would say don't guess D. I would have been wrong on this one. But in general, when you're guessing, do not guess the answers that say you cannot determine it. And that's not quite what this says. It doesn't say you can't determine it. It says there's no value of n that makes that true, and that's absolutely the case. There is no value of n. I cannot make what's inside that absolute value equal to -1, and that's what I would have to be able to do. However, I don't want to leave absolute value yet. There's a couple of absolute value questions on the test. I want you to know how to do absolute value. And it's real easy to teach you. It'll take me 2 seconds. If I say the absolute value of x is equal to 10, what does that mean? There's always means 2 things. It means what? X is equal to 10 or x is equal to -10. Okay, real simple. Now, if I say the absolute value of x minus 1 equals 10, now tell me the 2 things that are true.
-1.
Always do these by a method. I notice that you don't do that. I show you a method, then I ask you how to do it, and you do it by a completely different method. I want you to do it by the method that I'm teaching you.
Okay.
In other words, turn that into 2 equations. Just like when I said absolute value of that equals 10, I turned it into 2 equations. There's one, or x equals -10. There's the other one. That's the way I want you to do these. So if I say x minus 1, the absolute value of that is equal to 10. What 2 equations does that give you?
Do you have to do 10 minus 1 or and then?
Here's what you do. You take whatever's inside the absolute value, no matter what it is, and you set it equal to the number. In other words, the first thing is exactly what you're looking at, only remove the absolute value.
Okay.
The second thing is never change the inside. Whatever was inside, leave it there. But now it's equal to the opposite sign.
Okay.
So it's real simple. Whatever's inside the absolute value is equal to the number, or it's equal to the negative number. Now, the reason I've written them horizontally is so I can solve them vertically. So this one solves as x equals 11, and this one solves as x equals -9. So those are your 2 solutions. And notice that both of them work. 11 works, and -9 works.
Okay.
Okay? So that's how you solve absolute value problems. Now, if we were going to try to solve this problem by that technique, well, the first thing I would do would get that 1 on the other side. So I would have the absolute value of n minus 1 equals not 0, but -1. And unfortunately, that doesn't give you the proper solution. Nonetheless, that's the way. In other words, the only time this doesn't work, the method I just showed you, is when it's an impossible solution. In other words, the moment I'm looking at this, I should know this is impossible, because that always gives you a positive number. Always. Anytime you have absolute value, you have a positive number or zero, but you never get a negative number. So you can't have the absolute value of any quantity, no matter what it is. You cannot have it being equal to a negative number. So bingo, instantly.
Okay.
Number 9. Another very popular question on the SAT. It's where they give you, hold on a second, I think this refers to something above it. Yeah, questions 9 and 10 both refer to this.
Speed of sound and ear depends.
So, forget all the physics. Not a physics problem, this is a math problem. A strict math problem. What they love to do is give you an equation that has two variables in it and ask you to solve it for t. In other words, right now it is solved for a, correct? Well, let's solve it for t. I'm going to go over here, write it a little bigger. I want you to go through this step by step. And boy, you need practice on these. You definitely need to be able to know how to solve a linear equation, which is what this is. Remember what we want our last step to be. T equals. So, I got to get rid of everything that's with the t. What things are with the t? In what order do we get rid of them first?
You get rid of the 1.08.
No. You get rid of stuff that's being added or subtracted first.
So the 1052.
Huh? How do I get rid of it?
Subtract it.
Okay, from both sides. That gets rid of it over here. So now we're left with that. Now there's only one other thing affecting the t. It's the 1.08. How do I get rid of it?
Wait.
What is the 1.08 currently doing to the t?
Multiply it.
So what do you have to do to get rid of it? You always have to do the opposite.
Divide it.
Okay, I got to divide by 1.08, both sides. That cancels with that, and I've got my t all by itself. There's my answer. Let's see if we have it over here.
Yeah. Okay.
Remember to get rid of stuff that is being added or subtracted, especially when they're just numbers. And then get rid of the stuff that's multiplying or dividing. And then get rid of radical signs by squaring both sides. If you've got something that's x squared equal 4, you get rid of that exponent by taking the square root of both sides. And the square root of x squared is x. Square root of 4 is 2. So you definitely need to know how to solve simple equations. By simple, I mean linear. Linear is where there's two variables in them. If there's only one variable, then you actually can solve for that variable. Put a number on it. But if there's two variables, then you can always solve one variable in terms of the other, like the equation they gave us. But you can always also solve for the second variable in terms of a. Notice that every one of those answers is t equals something. That's why it's strictly a math problem. It's, if I gave you this equation, solve it for t. That's what the problem is.
Okay.
Now, let's see. Do we have enough time? Yeah, we probably do. To answer 10, and it refers to that same formula. So, at which of the following air temperatures will the speed of sound be closest to 1,000 feet per second? Well, the speed of sound is which letter?
Speed of sound, where is that at?
Well, you don't even need to see that. T is going to be what?
The speed of sound.
Oh, read the problem, number 10.
Which of the following air temperatures will the speed of sound be
What's
closest
T
to
going to be?
the temperature?
Okay, so what's the speed of sound got to be?
T.
A.
A.
There's only two variables there. There's an A and there's a T. And we know T is temperature. T is always either time or temperature. Okay? So A is the speed of sound. So they're saying which temperature, when I plug it in for T, do I get an A that's closest to 1,000? Well, that's pretty easy. If your life depended on this problem, what would you just do? You'd just plug in all four temperatures, right?
Mm-hmm.
And one of them is going to give you a number. Pick four numbers. Pick the one that's closest to 1,000. This problem is as simple as they get. In other words, if I start with 46, okay, well then I got A equals 1,052 plus 1.08 times minus 46. Well, if you do that on your calculator, I don't know what you get, but it looks pretty close to 1,000.
Mm-hmm.
Let me see. That might be the answer. 1.08 times 0.46 is almost 50. Almost 50. So that gives you an answer of A equals to 1,002. That's pretty close. 48 degrees. 48 times 1.08 gives you 52. That's closer.
Mm-hmm.
If that, in other words, when I use 48, then that's minus 52, and now A is exactly 1,000. So it's 48 degrees. In other words, all I got to do is back solve that. I don't have to do any algebra. I just got to plug in and take the answer that's closest to what they are asking for. Closest to 1,000 feet per second.
Mm-hmm.
All right, Haley, I will talk to you next Wednesday.
Thank you.
You're welcome. Happy Valentine's Day.
Happy Valentine's Day.
Almost forgot. Okay.
No.
Bye-bye.
Bye.